And all right, so I wanted to start with some vocabulary. Instance methods. So we talked about this in the functions lecture, but a method is a function that acts on a class instance. So this is a little bit different than a class method, although I might be saying these wrong for the specific JavaScript vocabulary, but a class method would be something like object.keys. Let's make an object first. That's my favorite. What's that? Of art. Let's see. So okay, and so now if we do this object.keys, notice we're not doing pets.keys, we're doing object.keys. So this is a class method. So object.keys, and then we put pets in there. Fine. So that's a class method. Although again, I would call it in Python. In JavaScript, classes work a little differently, so I might be getting the vocabulary wrong there. Whereas the methods that I'm going to talk about today are instance methods on arrays. So if I make an array, so you guys, somebody else had a pet too. Brittany, did you have a pet? What's your pet's name? Okay. All right. Anybody else want to add? Rufus the rat. Nice. Okay. And so now I can do pets array dot. Let's see. There's something out. Oh, I can also do. I think I can also do object dot keys pets array. This is because arrays are actually objects. This is going to be for the lecture on Wednesday for this prototypical inheritance, like how everything fits together. So the keys are 0, 1, 2, and 3, and the but I can also do pets array dot, and then there are functions that I can do, and those are going to be instance methods. And oh, look at that! So I did a tab twice, and it gave me all of my possible things. So I can do dot join, you know this one, and so if I join it all with a space, that's what I get. So join would be an instance array. Tab. So pets array dot tab. Okay, so cool. So now that we've got some of that vocabulary, and an important thing is that it has access to the instance's properties. It's really just like when I do pets array dot join here, it's like pets array as an argument to the join, right? Because if you just knew that it was a space, you wouldn't know that you were supposed to give back Cisco, Mochi, Kitty, Rufus, right? But it knows that I'm doing it on pets array, so it has access to all of that information that pets array contains, in addition to any arguments I give it, in this case, the space. Oh, that's right, this doesn't. Okay. It may return something, or it may actually mutate the instance right? Can you think of an array method that mutates the array, that changes the array? Dot sort. So if we go back here and we do pets array dot sort, it returns it. Has pets array changed? It has. So this one both returned the sorted array and it also changed the array in place. So I could say, let's do, here's another one that, that mutates the array. If I do pets array dot push, Aisha, do you have a pet? What's his name?
Braxton.
Like that? All right, now pets array is not sorted. Oh, well, Braxton's there twice. He's important, or she. Okay, so that mutated the array, it changed the array, and it returned the length of the array. So changing the array versus returning. And then if I say, now if I do pets array sort, I'll say sorted. Can do this. And the way sort works is now sorted pets. Not sure why it's, so sorted pets is like this, and then pets array is the same. It both mutated pets array and it returned sorted pets. All right, questions on instance methods or anything that I've done so far? Okay. All right, cool. So all right, so toString returns a string of the array. .fill replaces all array elements with whatever they are. And .pop removes the last element and returns it. Right, so this one doesn't mutate the array, just returns something. This one mutates the array. I'm not sure if it returns anything. And this one both mutates the array and returns something. Okay, instance methods. Now I'm going to shift a little bit and talk about another vocabulary word that I want to use here, which is functional programming. So when I interviewed for this job, Jeffrey, who was interviewing me, asked me about functional programming and object-oriented programming. It's a pretty typical question that people ask, functional programming versus object-oriented programming. And I think I wanted to change the slide, but that's fine. And sometimes it's a common misconception that object-oriented programming is when you have objects and classes and, you know, sort of this type of stuff that we're talking about a little bit here, and methods and so forth. And that functional programming is when you don't use those, right? It's just sort of like when you just go line by line and you're not using objects. But that's not true. Functional programming is not like the opposite of object-oriented programming. Functional programming is actually its own thing that has a very rigid way of looking at the world. And there are some programming languages like Haskell that only do functional programming. There's some programming languages like Java that only do object-oriented programming. And there are some programming languages like JavaScript or Python where you can do either or neither. You can just do regular iterative programming, not using objects and not doing using this functional programming paradigm. But basically, so here's the idea behind functional programming. First of all, you have pure functions. That's a technical term, pure functions. That means that anytime you give it the same inputs, you're going to get the same outputs. There's no saved state. So you're not saving state with a global variable. You're not saving state with a file. You're not saving state with a database. No saved state. Anytime you give the same inputs, you're going to get the same outputs. You can actually ignore this function composition for now. Yeah, so avoid shared state, avoid mutating state. So you can change variables from within a function, but don't change them outside a function. Don't change them in a way that's going to last outside the function. Yeah.
So, no saved state. Shared state.
Yeah, the state shared between functions.
And that's different. Is that the same?
It's the same thing. Yeah. And avoid side effects. So side effects are basically things that are going to last outside the function, that are going to outlive the function. And so that's things like changing a database, right? Or changing a global variable, or changing a file. And if they're necessary, because sometimes they are, right? Databases are useful in a lot of ways. If they're necessary, isolate them into their own functions. So you have some functions where state is, where there actually are going to change the state. Functional programming. So I want to talk about functional array methods. And these array methods that I'm going to talk about for the rest of this lecture, they take a function as an argument, and then they apply that function to each item in the array. So for each, and that hash mark, by the way, just means that this is an instance method and not a class method. I think array dot for each would mean then you actually literally do array dot for each, like object dot keys. But the hash mark means it's an instance of an array that you use for each on. Have you seen that before, Brittany?
I've seen it, but
Yeah.
I don't really understand the difference.
Okay, so we're going to look at for each, map, filter, and reduce. And you guys have, I'm sure, noticed that in your code reviews, I have been encouraging you to use these instead of for loops. All right, so for each. Yeah, using these instead of for loops, first of all, the code is cleaner. And second of all, it's more idiomatic JavaScript. And when I say idiomatic JavaScript, I mean it is the way people who are really familiar with JavaScript would write the code. Idiomatic JavaScript. All right, so for each, perform an operation on each element of the array, and it doesn't return anything. All right, so we have an array.forEach. The argument, like I said before, is a function. I'm using arrow notation here. And it's just going to console log whatever the element is. So I'll give you an example here. I saw that you were writing that. So let's see, pets array.forEach. And I'm going to say pet. And I'm going to just console log I love pet. You guys remember what this is called with the backticks? Template literal. Okay. Braxton gets double love. Okay, and then it returned undefined, which is, and the way the node REPL works, it just puts what it returns here. Since I didn't assign it, I could also say const output equals, and then, so output would be what? Undefined. The for each doesn't return anything. Okay. Okay, so let's, given an array of names, create an array of names, given an array of objects, each with a name key. So let's make an array of objects, each with a name key, and we want to create an array of names. Let's do this one in the editor. Okay, so let's say var pets. It's going to be an array. I think I might have already declared it. It's going to be an array of objects. So here's my array. Let's see. And then we'll do name. What's the rat's name again? Okay. So I have an array of objects, and I want to make this into just an array of the names, or I want to somehow generate an array of the names. So how can I do that using for each? I'm going to do pets.forEach, and what's the function going to be? Oh yeah. If I do object.keys, so if I do pet, and then I return, well, see, I can't do pets.keys. If I did, here, let's just run this. If I did pets.keys, what's it going to give me? Or sorry. Yeah. It's just going to give me the index, because pets, I could do, but that doesn't help me that much either. I want to collect, no, I think I'm just going to go to Adam. I want to collect all of the names. So we have this, and I'm going to do pets.forEach. How can I collect just the names? I have a pet, and the pet is going to represent each of these objects. I can. The problem is with the for each, what this returns is really not logged anywhere. You have an idea? Oh, thank you. Yeah, I think that's what we have to do. I'm going to make a names. I can do const because I'm not doing a new equal sign. I'm just going to be doing a push. And then I can do names.push pet.name. So I do this. Oh, because it's a const. So const names. But I just save automatically. I'll have to just save it somewhere, and then it won't matter. Okay, so Not great functional programming, by the way, because we had side effects. Names got changed. So let's think about how to make this better functional programming. And our answer is with map. Map is going to return a new array based on some adjustment to each element of the given array. Based on some manipulation of each element of the given array.
Does it right in place?
It doesn't do it right in place. It actually returns the new array. Whoops. So I have to say wow equals whatever. Whatever. We can use our pets array dot map, and then we can do wow whatever. So we can do here, we can do love array equals pets array dot map, and then we'll do pet. And this time what we return is important. So we're going to do I love pet dot name. So now whatever this returns is going to get sort of stored in a temporary array and then returned, and then we'll assign it to love array. I don't have a return statement here, so how do I know that it's returning I love pet name? Because it's a one-line arrow function. One-line arrow functions have an implicit return. It's just the way it is. Uh-oh. Okay. So my pets array was not an object. It was not the object. I don't know what my, does this do history? Nope. Does it do dot history? No. Let's see.
Pets object? Or just pets?
Yeah, I think just pets. But with this one, I could just do I love pet. That's fine. Because this one, I should have checked to see what my pets array was before I started. My pets array is just an array of strings. Better. And so love array now is going to be this. Pets array, unchanged.
The map returns a new array and leaves the original array.
Exactly.
Can you return that?
Say that again?
Can you return the love array function?
Oh, yes. Better? Actually, but this one, this is the one that actually.
Both for each and map except functions.
Exactly. Yes, both for each and map take a function as an argument. Okay, so our challenge here is give an array of integers, return an array with each value multiplied by 2. So here's an array of integers. And how can I return an array with each value multiplied by 2?
The array Number times 2.
Like this.
Bar.
What did we say that the argument had to be for map? Has to be a function. This is not a function. This is just an expression.
Right. No. Number and then arrow. Ah, that's good.
Yeah, so this makes it a function.
Oh, okay. Would you show an example? I'm still getting stuck with like one line arrow functions. So you could show for reference how you would write that same statement.
Yeah, definitely. So you would do like this, and then so it would look like this, and then it would just look, usually you'd see it like this. So you can use an arrow, or you can actually say,
That's what I used to write it. Okay.
and many times you will have multi-line functions. We're doing kind of simple things, but many times you will have multi-line functions. Okay. Okay, filter. Filter returns a new array with any elements of the given array that pass a test. So with map, we were returning new elements. We had a function that returned new elements. But with filter, we have a function that's going to return true or false. And if for your element it returns true, then it will be included in the filter function. And if it returns false, then it will not. So I'm going to do, I think I called this int array. Give me a minute to finish typing, and then I want somebody to explain to me why this would give you the odd numbers.
This modular returns the remainder, or I guess.
Yeah, it does, yeah.
So, so number modulo 2 means it doesn't divide evenly.
Yeah, but I mentioned that this needed to return a Boolean, right? And this here returns a number.
Zeros.
0 is falsy. Yeah. Yeah, that's what you were going to say, Misha. Yeah, 0 is falsy. If this returns 0, then this is going to evaluate to false. It's going to be like, what Boolean did you return? You returned false. And so if this is 0, it's not going to include those numbers. If it's 1, 1 is truthy. So it does include these numbers. So I'm taking a shortcut here. This is not really a Boolean, but it evaluates as a Boolean. What filter does it is it evaluates whatever comes out of your function as truthy or falsy. So what if I wanted all of the odd numbers instead? I mean, even numbers instead. Yeah, you can't do not on the modulo, unfortunately. I could do this. Okay, fine. Yes, I'm going to save it as untitled under data modeling. No, hold on. .js, that'll at least give us okay. Okay, so yeah, so now odds has already been declared. So let's try that again. And I'm going to do this var because we might do this a couple times. Okay, so now we have sort of the logical opposite or the Boolean opposite of whatever this is. That's what the not does. You could also say, that'll work too. Now I'm actually returning a Boolean.
It always gets
Yeah.
so wouldn't it be L modulus 3?
No. So yeah, no, it's just you want, if it's even, you want your element modulo 2 to equal 0. And if it's odd, you want it to equal 1. Because it's like basically what you're saying is take your number, divide it by 2, and what's the remainder? If you divide 5 by 2, the remainder is 1. If you divide 4 by 2, the remainder is 0. Yeah, because if we put a 3 here, then we're going to get things that are evenly divisible by 3. Yeah, it's it definitely is. It's kind of a weird concept. Okay, so our challenge is to filter for strings that are longer than 5 characters. Let's do that with our pets. So if I do pets array, okay, so we want strings that are longer than 5 characters. I think Braxton's gonna be our only result here. So how would I do that? Pets array dot filter. And what's my function going to be? We want anyone that is longer than 5.
So that dot range.
And Brittany, if I hit return, I'm going to get an error.
That's right. Area zero.
It needs to be a function. Yeah, nice catch. Okay. How's it going? Reduce. Oh, and all of these, by the way, I have a link to the MDN documentation. Okay, so reduce. Reduce is commonly used to sum up elements in an array. So what reduce does is it takes your accumulator. So my accumulator here is A, and my element is an element. And it returns whatever your accumulator is plus, and then, whatever you want to return becomes your new accumulator. So if I am running this on my 1, 2, 3, 6, when I start my accumulator as 0, it defaults to 0, although I can give another argument after my function and say what I want my accumulator to start as. So my accumulator will start as 0, and the first element is 1, and it's going to return 1. So now that's going to become my new accumulator. And then, so now we have the accumulator 1, and my element is 2. So now my new accumulator is going to be 3. My third element happened to be 3. So my accumulator is 3, and my element is 3. My new accumulator is going to be 6. And then because apparently I'm perverse, my next element is 6. So it's going to be 6 is my accumulator. 6 happened to be the next element. And then it's going to return 12, which is the sum of all the elements. Would it help if I wrote that out on the whiteboard? That's good. Accumulator and the number. And I can even call it, like running total and the number. And I want to return whatever the running total is plus the number. And I can be explicit and say I want to start I want my accumulator to start at 0.
You always have to are you passing 2 arguments?
I am. It's the accumulator and whatever I'm going to call the element this time around. Yeah, Isha. So to get it to print at each iteration, good. We're going to get a multi-line function. That's good. So now I can make the function be multi-line, and this I think it's just a mess. I don't love this, but so first I am going to console log and then now I have to explicitly return because I'm not on the first line of an arrow function anymore. So now it'll say we're looking at number something, the running total is something, and then it will continue accumulating. We're looking at 1, the running total is 0 because we haven't returned it yet. So that's just was at the start. Looking at 2, the running total was 1. And then, yeah, because of the way I chose this array, it like goes to 3, 3, 6. But let me just do, okay, okay, so now when we're looking at 2, the running total is 0. When we're looking at 6, the running total is 2 because all it had was 2. Because we're always going to get the running total before we've added our current number. When we're looking at 1, the running total is 8 because it did 2 plus 6. And when we're looking at that last number, the running total is 9 because it was 2, 6, 1. And then finally, it returns 16. It returns whatever the running total was after that last iteration.
Can you describe an instance where you would use reduce?
This is definitely an instance where you would use reduce. I recommended, Celeste, at one point that you use reduce for something, but now I'm not remembering what it was.
Yeah, and it was find the longest name.
Find the longest name. Should we find the longest name in our pets array? Okay. So we have our pets array. And we're going to have longest name pet. Let's start with the longest name is an empty string. That's going to be my start for the accumulator. What do I want to return? Yeah, let's use a ternary. If pet.length is greater than longest name.length, then I want to return pet. Or if, yeah, that's fine. Otherwise, I want to return whatever my current longest name is. Just leave the accumulator the same. I love ternary. Love them. They're so compact. About ternary? Sure. Ask about them in office hours tomorrow.
So what that will do is it will, when you iterate through each time, it'll take the current iteration, compare it to the value stored in longest name,
Which is our accumulator at this point.
which is your accumulator. If it's greater than that, it'll reassign.
It'll return pet. And what filter or what reduce does is it reassigns the accumulator to whatever is returned. Right? Because here, remember, we were just returning this. And otherwise, we'll just keep it at whatever it was before. Yeah. And we might have a problem if two of them have equal names. We're going to be ignoring one of them. But in this case, they're both Braxtons. So, all right. So shall we try this? Other questions on this?
When it's written out, with your line arrow.
Yeah, I think I can do. I think I'm anticipating your question, Brittany. Are you asking about the implicit return?
No.
Oh.
I guess that would be a second question.
Okay.
Now, if you don't put it all on one line, you have to add that second argument or bit where you declare what it starts at.
No, yeah. So no. This is just for reduce, and I didn't put what it starts at. Yeah, I actually did here, but in the slide I didn't because it defaults to 0 if you don't specify anything. But that's something, I don't know, that's a piece of information that maybe if you use reduce all the time, you'd want to keep in the back of your brain. But I'd say to be safe, you should probably always just put what you want the accumulator to start as.
It default to 0. Does it default to 0 in that last one?
Yeah. So this, what do you think this is going to do? When it gets to doing 0 dot length, okay, so let's try. Oh, no, I guess maybe it was smart enough to know that it was the empty string. I thought I've gotten instances where it throws an error. Yeah.
So when it's not an array of numbers.
Oh, I guess, okay, so it just does undefined here. Oh, it's because of the way freaking objects work. If this happened to be a method instead of a property, then we would have had problems. Yeah, JavaScript.
I could just do say 0 or 1 plus plus and have it change on every time that it goes.
The accumulator?
Yeah. I don't know in what case you would do that for. I'm just curious.
What does? Yeah, I think you can. If I say a equals 3 plus plus. What is 3? Does 3 plus plus? Okay, interesting. Notice that it's not returning 4, it's returning 3. I think if you do plus plus a, yeah, if you do plus plus a, it'll, yeah. So, and we can talk about this later if you want. You would probably have to do the plus plus a instead of the a plus plus, so that it returns the right thing. But as long as it's returning the right thing, you're okay. Okay, so create a string that contains the first letters of each word in an array. I'll let you guys do that challenge on your own. We already did a string challenge where we found the longest string. So chaining. So you can chain, filter, and map, for example, to process an array of objects. So first, we're going to filter for only cats, and then we're going to map to the name of that cat. So what is cat names going to actually be in this case? An array with 2 elements, Fluffy and Cisco. Because first it's going to filter to an array of 2 objects without poor Bruiser. And then it is going to map each of those objects to the name, to the value of their name property. Questions on this? Okay, so let's do a couple of challenges. Let's see what the time is like. We've got 3 minutes. All right, so maybe we may only have time for challenge number 1. Given an array of arrays, create an array containing the largest number in each subarray. I think actually, as I was writing this lecture, yeah, I'm not as interested in the second one. I think as I was writing this lecture, a learner came up to me with this exact problem. So given an array of arrays, create an array containing the largest number in each subarray.
Okay. Iterate through the memory.
Okay, well, we're going to have to do this using functional methods. Yeah, okay. So tell me, what am I going to type?
So,
But you can continue your thought. I just want to make sure we're not doing any sort of for loops.
No.
Yeah, okay.
So you're gonna iterate through. So like for each element. And you arrow notation. So for each element, arrow. Function. So open curly bracket, and then you do element or that array dot reduce. Oh wait, we're trying to get the largest number for each one. And so we write a line similar with another number arrow notation, curly bracket, and then write a line similar to what we wrote up there. So return number greater than longest number. And then you would have to, I missed the slot, and then in your reduce function, you would have to do which number, largest number, comma number.
Largest number, comma number?
In the second line, element dot reduce.
Right here?
Yeah. So in your.
Oh, what if I were to use map instead?
Did that.
Yeah, that's all good.
What would happen?
You would return the array.
Uh-huh.
return an array of numbers.
And what numbers would they be?
They would be the largest numbers.
Which is what we wanted. So let's see.
What the question was.
Uh-oh. Largest number is not defined.
Yeah, that's what I think. So,
Oh, that's what you were saying. Got it.
yeah,
Oh.
reduced, yeah. And would you just start your accumulator? Nope, you would. Accumulator
It would, yeah, but we can just say 0. Or in this case, you probably would want to do something like undefined and then check to see whether it was undefined, and if it was, then not included or something in case it was like a string or I don't know. But for our purposes, especially since it's 1101, we'll just do this. Oh, what's going on there? Did I get the order? Longest name, pet, largest number.
setting your accumulator.
Maybe. This would be pretty poor because what if I had negative numbers and so forth? So I would have to do something a little bit classier there. But I have only positive numbers. So if we say that's part of the problem definition. Sorry, we've got some debugging. You can come in and sit down. You can help with our debugging. Trying to figure out why this is giving us an array of all undefined rather than an array of the largest numbers. So I'm doing some print debugging here. Okay. Oh, I think it's because I'm not returning this. So this function, what is this function returning? That function is returning undefined because it has no explicit return.
We need to return elements.
Yeah. Let's try this. Ah, better. Print debugging is really useful as a debugging tool. It's like, oh, there was nothing wrong with my actual numbers, so there must have been something wrong with my process. Cool. I will, phase 1, I'll send out the slides. The slides also have, which I didn't get a chance to talk about, they have another challenge to flatten this array. And then I have some resources. There's some good exercises you can do if you want to practice this, if you want to understand the inner workings, and then if you want to understand more about functional programming. So, okay, yeah. You're welcome. Yeah, of course. Okay.
Phase 1 all over again.
Okay, so I'm going to end this meeting.